Question number 8 here. Find the equation on the plane with intercept 3 on the y-axis. On y-axis, intercept equals to 3. Intercept, that small b equals to 3. That's given to you. And plane is parallel to, this is given to you, parallel to ZOX plane. So if I draw the rough diagram, you will realize what it tried to say is, let's see this 3 coordinate axis here. If I draw 3 coordinate axis, this is x-axis, this is y-axis, and this is z-axis. Here this is origin. Now plane is parallel to the ZOX plane. So it would be like this. For example, this is the required plane. It is parallel to this. So you can see that it will never cut Z and X axis. Right? It's parallel to this plane. This is the plane you can see. And it is parallel to this plane. This is the plane here. Inside this is your plane. So it's parallel to this plane here, remember. It will never cut Z and X axis. So therefore you can say that intercepts on X and Z axis are undefined. Fine. So therefore required plane here, x upon a undefined plus y upon b here. What is y upon b? Which is 3 plus z upon c undefined equals to 1. Which form you have used? X upon a plus y upon b plus z upon c equals to 1. But there, this is not defined, so this term will not be there. C is also not defined, this term will not be there. You have just this one, and therefore y equals to 3. Right? This is the required plane here. Y equals to 3. Okay, 9th question. This is based on one of the theory, if you remember. What you are asked, find the plane through the intersection of this 2 plane and also passes 3, 2, 2, 1. So we use which theory? If you just recall, we use one plane plus lambda into the other plane, plane number 2, plane number 1 equals to 0, if you remember, where lambda is a scalar. First we write this, we get the lambda using that condition that plane passes through 2 to 1, and then in turn we place into this. That's what we want to do. Fine. There's the theory. Now I'll be doing this. So I'll write here required plane. What's the required plane? One plane. One plane is given by what? Here 3x minus y plus 2z minus 4 plus lambda into the other plane. What is the other plane here? The other plane is x plus y plus z minus 2 equals to 0. We call this as equation number 1, and where lambda is a scalar, remember. Okay, now we find the lambda, because this is not just one plane. These are the number of planes as I explained in the theory. Go through the theory. So now I'll write this plane as it is passes through the required plane you are given in the question. ये कहाँ से pass हो रहा है? It passes through. You are given one point. 2, 2, 1. This plane passes through this point. That means this point satisfies the equation of the plane. Fine. So here, if I just try to draw the diagram, you will realize probably. For example, this is one plane here, given plane. Let me draw one more plane here. This is another given plane. Our required plane is this, that passes through the intersection of this. Our required plane may be like this, for example. And point is there. Which point? 2, 2, 1, which is on the give required plane, remember. So the coordinates of this satisfy this equation. Therefore, instead of x, y, and z, you are going to place this value. So here 6 minus 2 plus 2 minus 4 plus lambda into, what is this? 2 plus 2 plus 1 minus 2 equals to 0. So from this, what we'll get? Lambda. And then we put in equation number 1. Finished. So lambda is here minus 2 by 3. Now where we put the value of lambda? In the equation number 1. So by 1, you have 3x minus 2y, just y, plus 2z minus 4 minus 2 by 3 into x plus y plus z minus 2 equals to 0. So here you will get the 9x minus 3y plus 6z minus 4. No, 3 4s are here, it is 12, sorry. So this is 12. This is here 2x plus 2y plus 2z minus 4 equals to 0. So 9 minus 2, which is 7x, minus 3 minus 2y, which is minus 5y, 6 minus 2, which is nothing but the 4z, and minus 12 plus 4, it would be here minus 8 equals to 0. That's a required plane, right? So whenever you have the word, which is important word here, that the plane through the intersection of these two. Next is the same question. Even 11th is also same question, but their condition is different. 9th, 10th, and 11th. In these three questions, you have plane through the intersection of the given two planes, remember. So whenever you have through the intersection of the given two planes, then the theory is one plane plus lambda into the other plane equals to 0. Right? That's what we need to do here. So 9th I did, 10th is just same question. You just copy this. Their equations are in vector form, so you can write in Cartesian form. For example, what is the first one? That is 2x plus 2y minus 3z equals to 7. In the 10th question, if I see the equation 2x plus 2y minus 3z minus 7 equals to 0. So put here. What about the other one? That is nothing but 2x plus 5y plus 3z minus 9 equals to 0. You can put this much over here and get the lambda using which condition? That instead of here 2 2 1, there the point is which one? 2 1 3, and just in place of here lambda you put the value and simplify. I'll be doing 11th question. Procedure is same, but your condition is different, remember. So in the 11th question, question number 11, find the equation of the plane through the intersection of the given two planes. So here given planes are this. You write the given planes, remember. I'll write the required plane here. So required plane is given by what? One plane, which is x plus y plus z minus 1. You must have equals to 0 form, remember. Plus lambda into 2x plus 3y plus 4z minus 5 equals to 0. This is our required plane. We call this as equation number 1, and lambda is a scalar which we need to find from the condition given in the question. Now which condition you are given here? That the required plane is perpendicular to this plane. Now here Required plane and the given plane are perpendicular, so I need the normal to this plane. So I'll just rewrite this equation in ax plus by plus cz form. So what I'll do, I'll take x common from this 2. So what we'll get? 1 from here and 2 lambda from here, plus I'll take y common from this. So I'll get the 1 from here and plus 3 lambda into y. 3 lambda into y. Just open the bracket, you will realize. Plus z common from this 2. This one and this one. So what we'll get here? 1 from here and 4 lambda from here into z. And constant term, here we have minus 1, and this is nothing but minus 5 lambda equals to 0. Right? What I did, I have expressed in which form? You can see ax plus by plus cz plus d equals to 0. Why I did, you will realize in few minutes. I repeat this, taking x common from this, so 2 lambda and 1 from here. Taking y common from this, so 1 plus 3 lambda into y. 1 plus 4 lambda into z. This is minus 1 and minus 5 lambda. Now this plane is, alright, is what's given to you? Perpendicular to, this is given in the question, perpendicular to the plane. One more plane you are given, one more plane, that is x minus y plus z equals to 0. So therefore what happens? These two planes are perpendicular. If planes are perpendicular, it's like this in a diagram you see. Suppose one plane is this, I'm putting here. This is another plane, right? These two planes are perpendicular, you can see. Okay. Now what is the normal to this plane? It is here, you can see. And what is the normal to the other plane? This plane, that is here. So what can you predict about these two normal? This plane and this plane are perpendicular. This is a normal to this plane and this is a normal to this plane. So what happens to the normal? Can you tell me? Normals are obviously perpendicular. These are the two normals you can see. Fine. So I'll write here, therefore their normals are perpendicular. Their normals are perpendicular. So get the normal. That's why I've expressed in this form. You can get the normal only when you have ax plus by plus cz plus d form, remember. So what's the normal to the first plane? That is here 1 plus 2 lambda, comma 1 plus 3 lambda, comma 1 plus 4 lambda. That's the normal to the first plane. Dot, once the normals are perpendicular, dot product of the normals equals to 0. What's the normal to this? 1 minus 1, 1 equals to 0. Which concept you have used? Normals are perpendicular. Therefore, the dot product of the normal, this normal dot this normal equals to 0. Perpendicular means dot product equals to 0. Now, what's the normal to the first plane? Coefficient of x, y, and z. And what's the normal to the second plane? 1 minus 1 and 1. Now we just multiply, so we'll get the lambda and you place there. So 1 plus lambda into 1, which is 1 plus 2 lambda. Here you are multiplying with minus 1, so minus 1 minus 3 lambda. Here you are multiplying with 1, so 1 plus 4 lambda equals to 0. This into this, this into this, this into this. So here 4 plus 2, 6 minus 3, so 3 lambda. Minus 1, 1 will get cancelled, plus 1 equals to 0. Okay, so you are getting lambda equals to finally minus 1 by 3. Now we put these values where? In equation number 1 and we'll simplify. So by 1 here, x plus y plus z minus 1 minus 1 by 3, 2x plus 3y plus 4z minus 5 equals to 0. What I did, just I placed the value of lambda. Now we are simplifying. So you will get the 3x plus 3y plus 3z minus 1 equals to minus 2x minus 3y minus 4z plus 5 equals to 0. So 3x minus 2x is just x. 3y will goes away. Minus z. And here minus 1. But I suppose this should be 3 again. So minus 3 plus 5. So it will be plus 2 equals to 0. This is a required plane from the equation number 1. Question number 12. Find the angle between two planes whose vector equations are there. You just need the normals. So I'll write the normal to the first plane. What is that? That is 2 comma 2 comma minus 3. Right? Equations are this form. R dot normal equals to D. Normal means what? You know, coefficients of x, y and z here. So 2, 2 minus 3. And normal to the second plane. What's the normal to the second plane? That is 3 comma minus 3 comma 5. 3 comma minus 3 comma 5. Fine. Now let theta be the measure of angle between two planes. So angle between two planes. So therefore, if you just recall the formula, cos theta equals to modulus of n1 dot n2 upon their individual magnitude. You know this, right? Number of times we have used from vectors. Okay. Now dot product. What's a dot product? Here it is 2 into 3, which is 6. This into this, which is minus 6 minus 15 upon root of, what's this? 4 plus 9. What is this? 9 plus 25. So therefore cos theta equals to here 15 upon, if we simplify, so here this is root 17 into, what is this? This would be root 43. So cos theta will be here 15 upon root, just multiply these two, so 731. And therefore theta will be cos inverse 15 upon root 731. That's the angle between two planes. The question number 13, you are asked whether the given planes are parallel, perpendicular, and in each case you get the angle between them whenever it is possible. Okay. So what you need to do, you get the normals to two planes. If normals are parallel, what is the meaning of parallel? That is, they are multiples. K into normal n2. In this case, two planes are parallel. Planes are parallel. So angle between two planes is 0. Theta is 0. The second possibility, if normals are perpendicular, that is, the dot product is 0 here. That means two planes are, in this case, two planes are perpendicular. Perpendicular planes, remember. So the angle between two planes is what? Here pi by 2 or 90 degree. And if the normals are not parallel, not perpendicular, then use the formula to get the angle between two planes, cos theta equals to, as we did in the previous question. Right? So every time you need to observe these two things mainly. One is this and the other one is this. Okay, so have a look at the first sub question. There, what's a normal to the first plane? You can see it is 7, 5 and 6 coefficients of x, y and z. What's normal to the second plane? Which is given by 3, minus 1 and minus 10. coefficients of x, y, z. 7, 5, 6, 3 minus 1 minus 10. Now by the first observation you can see that they are not multiples. That's the first observation. The next point is what you need to see. What's a dot product? So 21 minus 5 and here minus 60. So dot product is also not 0. So here you can say that this is not equals to this. They are not multiple. And dot product is also not 0, remember. So they are neither parallel no perpendicular. So they must have some acute angle. So we use this formula now. We use which formula? We use cos theta equals to, modulus of n1 dot n2 upon their individual modulus. We use this formula. To find the angle between two planes. Now place the value and just get the theta from this. So we'll get the cos inverse here, the value. This is not a big task for you, so you can do it. See the second question. What about the second question? Write the normals to two planes. What's the normal to the first plane here? For the second sub question, normal to the first plane, which is given by 2, 1, 3. And normal to the second plane. What's the normal to the second plane? That is 1, minus 2, z is not there. Remember, it's 0. How do we get the normals? I just remind you, if this is the plane, then normal just represent coefficients of x, y, and z. Remember, a, b, c. Now these are not multiples. That's quite obvious. But if you look at a dot product, you will notice that it is 0. 2 into 1, which is 2, plus this into this, which is 2, plus 0. So we'll get the 0 here. So n1 dot n2 equals to 0. Therefore, planes are perpendicular. Therefore, planes are perpendicular. That means the angle between two planes is 90 degree or pi by 2, whichever you write. Next question. What about next? Question number C, third sub question. There, what's a normal to the first plane? Normal to the first plane, you can see it is 2, minus 2, 4. And normal to the second plane, it is 3, minus 3, 6. Fine. Normal to the first plane, 2 minus 2, 4. Coefficients of x, y, z. 3 minus 3, 6. Now here, you can see that they are multiples. You can write here n normal equals to some constant into the other normal. Now what's the scalar? You try to find it. I leave it for you. This may be positive or negative. That's not important. If you multiply with some constant to the second one, you will get the first one. Think for a while, but this is true, remember. And therefore, what's the conclusion? Planes are parallel. Fine. Go to last two questions same way. So that's for you. D and E, I leave it to you. The same way you need to do. Okay. Question number 14. What's question number 14? There you want to get the distance of each of the given points from the plane. Okay. So in all these four sub questions, we use which formula here? If you remember, we use modulus of ax1 plus by1 plus cz1 plus t upon under root a square plus b square plus c square. This is the perpendicular distance, or you can say that the perpendicular distance of the point x1, y1, z1 from the given plane. Here plane is which one? That is ax plus by plus cz plus d equals to 0, and the point is your x1, y1, z1. Right? This is just theory portion I already discussed earlier. So this gives us the distance. You can write small d, for example. replace x, y, z by x1, y1, z1, and upon the length of the normal, that's the coefficient of x, y, and z. See the first question here. Their point, which is here 0, 0, 0, that's origin, which is x1, y1, z1. So you are just left with modulus d here, and plane is given by 3x minus 4y plus 12z minus 3 equals to 0, and therefore the distance d equals to modulus 0, 0, 0. You are left with just minus 3 here upon root of a square plus b square plus c square. So we'll get the 9 plus 16 plus 144 here. So from this you will get the d equals to, what is d? That is, this is 169. So we'll get the 3 upon 13. Second sub question. The second sub question, which fixed point you are given? The point is, your point is 3 comma minus 2 comma 1, and the plane is given by which expression? 2x minus y plus 2z plus 3 equals to 0. So the distance small d equals to modulus of 2 into 3 minus y, that is here minus 2, so they become plus 2. 2 into 1, that is just 2, plus 3 upon root of a square plus b square plus c square, which is 4 plus 1 plus 4. So if we simplify this here, the numerator will be here 13 upon root 9, which gives us 3. Okay, let's see one more sub question there. Sub question D here. There the point is given by minus 6 comma 0 comma 0, and plane is given by which equation? 2x minus 3y plus 6z minus 2 equals to 0. So, therefore the distance small d equals to modulus of 2 into minus 6, 3 into 0, so 0, plus 6 into 0, which is 0, and minus 2 here upon root of a square plus b square plus c square. So 4 plus 9 plus 36. So this will be here minus 12 minus 2, so minus 14, but because of the modulus it would be 14. This is just 7, so we'll get the 2. This the required perpendicular distance.